Another striking example of how healthy fat cells safeguard metabolic balance is the secretion of adiponectin, a hormone almost exclusively produced by adipocytes that plays a central role in enhancing insulin sensitivity and maintaining glucose homeostasis. Unlike many adipokines that increase with rising fat mass, adiponectin levels paradoxically decrease in obesity, suggesting that it is not the quantity of fat, but its functional state that determines metabolic health. Adiponectin circulates in high concentrations in lean, healthy individuals and exerts insulin-sensitizing effects primarily on skeletal muscle and the liver. In muscle, it activates AMP-activated protein kinase, (AMPK), which increases glucose uptake and fatty acid oxidation, processes that lower blood sugar and reduce circulating lipid levels. In the liver, adiponectin suppresses gluconeogenesis, glucose production, and enhances insulin signaling pathways, preventing excessive glucose output that could lead to hyperglycemia. These combined actions make adiponectin one of the body's most potent natural protectors against insulin resistance and type 2 diabetes. Another crucial aspect of adiponectin's function is its role in maintaining healthy fat storage capacity. Adiponectin promotes the formation of new, small adipocytes, a process called hyperplasia, rather than forcing existing fat cells to become excessively enlarged. This healthy expansion allows adipose tissue to safely store incoming lipids in specialized fat depots, preventing ectopic fat deposition in non-adipose organs like the liver, pancreas, heart, and skeletal muscle. When fat spills into these tissues, it disrupts their function and contributes to insulin resistance, fatty liver disease, and cardiovascular complications. By encouraging the proper expansion and turnover of adipose tissue, adiponectin protects against these lipotoxic effects. The protective role of adiponectin has been vividly demonstrated in experimental models. In mice engineered to overproduce adiponectin, researchers observed increased fat mass, but markedly improved glucose tolerance and insulin sensitivity, highlighting that well-functioning adipocytes, even in larger numbers, can be metabolically beneficial when they secrete sufficient adiponectin. Conversely, adiponectin-deficient mice develop insulin resistance, glucose intolerance, and increased inflammation, underscoring its necessity for metabolic resilience. Human studies echo these findings, showing that higher adiponectin levels correlate strongly with better blood sugar control, lower risk of type 2 diabetes, and reduced cardiovascular disease. Intriguingly, centenarians, individuals who live to 100 years or more, often have elevated adiponectin levels, suggesting that maintaining robust adiponectin signaling may support longevity by preserving insulin sensitivity and reducing chronic inflammation. Moreover, adiponectin exerts powerful anti-inflammatory and anti-atherogenic effects. It suppresses the production of pro-inflammatory cytokines like TNF-A while stimulating anti-inflammatory factors such as IL-10, thereby dampening harmful inflammation that can damage blood vessels and promote atherosclerosis. It also protects endothelial cells lining blood vessels and inhibits the formation of plaques, reducing the risk of heart attacks and strokes. Together, these diverse and beneficial actions of adiponectin make it a prime example of how healthy adipose tissue supports whole-body metabolic health. Rather than being inert or harmful, fat cells that secrete sufficient adiponectin act as guardians of insulin sensitivity, ensuring efficient nutrient use while shielding organs from lipid overload. This evidence reinforces the idea that the functional quality of adipocytes, particularly their capacity to produce hormones like adiponectin, is a key determinant of systemic health, highlighting adipose tissue as an essential and dynamic regulator of metabolism.